Good morning to all. We are discussing the unit number 5, that is secondary storage management. And under the secondary storage management, we are discussing the disk scheduling algorithm. So we have discussed about the 6 disk scheduling algorithm. First come, first serve, the first scheduling algorithm. Second one is nothing but the SSTF, shortest seek time first. The third one is nothing but the scan. The fourth is nothing but the C scan or the circular scan scheduling algorithm. The fifth one is the look, and the sixth is nothing but the C look, that is circular look disk scheduling algorithm. Also, we have discussed about why there is a necessity of the disk scheduling. Right. So disk scheduling is required because multiple number of requests are arrived, and the disk is the one can say that the speed of the disk is slow as compared to the execution speed of the processes. So at a time we can observe that there are multiple number of processes, they are requesting different IO operations, but the disk is unable to, or the disk controller is unable to service all the requests at the same time. That's why there is a queue, there is a formation of queue of all these multiple requests. Right. So there are, one can say that there are 10, 100 or n number of request processes, they are requesting the disk operations, whether it is a read operation, write operation, or any operation that is to be performed on the disk. Right. So if there are multiple number of processes, or if there are multiple number of requests, so it is the duty of the operating system. It is the duty of operating system to allocate, to allow the particular request to serve and get it executed. So this thing is carried out with the help of different scheduling algorithms. Right? There are, means you are applying logic here. You are applying either first come first serve, means as the arrival of the process is taken, and then when the process arrives first, the request of that particular process executed first, or the service first. Or second category is nothing but SSTF. So we have to find out the how much is the seek time, or how much is the distance travel by that particular disk arm. Depending upon that seek time or the seek length, the minimum is the seek length or the minimum is the seek time. That request will be serviced first, and the seek length having the greater distance will be serviced afterwards. In case of your SSTF, shortest seek time first. In case of scan scheduling algorithm, the disk head is scanning entire disk
छत्तीस
from
पड़ी सर नहीं
end of the disk towards the another end of the disk. That is
हेलो
algorithm, or also called as the
हेलो
elevator algorithm. Next, nothing but the circular scan. In
हेलो
case of circular scan, it is
हेलो
similar to scan. The thing is that when the disk arm reverse its path, or when it
सर
travels
पीपीटी एका स्लाइड वरती अटकली
service any of the request in the
सर
from the path,
लिखी सावधान है सर ने
get of the start position and then start servicing the request. The next one is nothing but your look algorithm. So look algorithm is similar to scan algorithm because scan is not practically possible, right? So look algorithm is practically possible. It is actually implemented in the
हेलो
operating system. So the look algorithm says that
हेलो हेलो हेलो
look algorithm says that what we have to do here, the last request on either of the side, when it is if it is on the first, if it is on the right hand side or the left hand side, so that will be considered on the both sides. The last request, the head will move toward the last request, will not reach to the end of that particular disk, and automatically then it will move toward the next direction. C loop is nothing but the circular
हेलो हेलो
loop algorithm. It works exactly as that of the loop algorithm. So what happened in this case? In this case also, it will the head will not move to the extreme ends, but it will service, or it will move up to the end of the last request, or the it will move to the last request only, and then it will reverse the direction. But while reversing the direction, or while traversing the reverse path, it will not going to service any request. So we have seen a few examples in the previous lectures. Today also we are going to discuss some of the examples based on these algorithms. So see here on the PPT, this is the first example I think we have already discussed in the previous lecture. Now we will go for the next example, right? So this one is the SSTF and the scan scheduling. Okay, so this one example is complete here. The next example, see, read it carefully. A disk drive has 640 cylinders. Read the example carefully. A disk drive has 640 cylinders. number from 0 to 639. Number 640 cylinders, number from 0 to 639. What is the meaning of this? Meaning of this is that your x-axis must contain how many numbers? 0, say for example here 50, then we have 100, then we have 150, then we have 200. So this way we have to go up to 650, for example, right? This is the case. Then this drive is currently servicing the request at cylinder 200. So 200 means current head position is here 200. For example, this is the current head position. The request queue of the pending request in FIFO order is 184, means this is the request order. The request arrive in the order 184, request come first, then the request come for the 153, then it come for the 232, 128, 25, 533, 161 and 169. So how many requests are there? This is 1, 2, this is the third request, 4, 5, 6, 7 and 8 requests. So total number of requests are 8, right? So starting from the current head position, what is the total distance that the arm moves to satisfy all the pending requests for the following scheduling algorithm? So FIFO, SSTF, scan, C-scan and loop. Right. So 5 algorithm we have to find out the average seek length or the average seek time. So first is nothing but your FCFS scheduling. So FCFS is the simple one. The request will be serviced as per their arrival order. So see here, next track travels, and the head starting at 200 location. Head starting at the 200 location. The first request is means from the current head location, the arm moves from 200 to 184 location. Right, as per their arrival order, there is no any additional thing is required. So from 184 to 153, from 153 to 232, then from 180, 128, then from 128 it will go to 225, then from 25 it will move to 533. See the distance travel. So this is the distance travel. 533 minus 25. 508 is the distance travel. So this is nothing but the subtraction. 200 minus 184, 16. Then 184 minus 153, 31. 232 minus 153 is 79. 232 minus 128 is nothing but 104. 128 minus 25, 103. 533 minus 25 is 508. 533 minus 161 is 372. And 161 minus 169 is 8. So this is the total last request is 169. So total distance travel by that particular disk arm to service all the requests is 1221 divided by how many requests are there? There are 8 requests. So you will get your average seek time AST, or you can also call it as average seek length. So this is the way how it executes. You have to draw the graph in this way. So see it once again. See the disk arm movement. Okay, so from 200 is the current head position. It will from 200 to move to 184, then to 153, then to 232, then to 128, then 25. And when it reaches to 25, the next request is 533. So see this much amount of the distance it need to be traveled by that particular head disk arm. Then from 533 it will come back again to 161 and finally 169 it will stop here. So you will have average seek length equal to 1221 divided by 8, that is equal to 152.62 is nothing but the average seek length. So this is all about your FCFS scheduling, that is nothing but the first come first serve. Then the second algorithm is nothing but your shortest seek time first. So in case of shortest seek time first, again first of all you have to draw the table. So it will start from 200 location. It will start from the 200 location. Now we have to see from current head position which is the request, which request is nearer to the current head location. So out of 184, 169, 161, 153, and of course that request must be in the left hand on that right hand side direction. Means it will move in this it will move in this direction always. It will not move to in this direction. See this point you have to remember. So from you can have means you have to see which request is the nearer to that particular current head position. So 200, 184, 169, 161. So 184 is nearer because the distance is only 16 from 200. Now the current head position is 184. Current head position is 184. So from 184, which is the nearer one? So from 284, 169 number is the nearer one. The distance is 15 only. The distance is 15 only, right? So it will move to 169. Now from 169, which is the shortest, so we have to find out the shortest distance from every current location, because the next location the new location becomes the current head location, and from that current head location we have to find out the best one. For 161 is the shortest to 169, so that is nothing but the 8. So for 161 the nearer location is 153, 153 is 128. See here, these are the distances, or these are the subtraction. Now from 128 it will go to 25 because the distance is 103. So this distance you have to calculate first here. So here you will find here all these are the ready-made value, but while you are solving this example, this value are not available to you. You have to yourself find out this value, which location is nearer to that particular current head position, right? Then from 25 it will move to 232. The distance is 207, and from 232 it will move to 301. So total distance travel is nothing but your 683, right? So see here. So this is the way how the disk arc moves. So see, so you will find that this, see the length of the arrow. So in the SSTF you have to observe the length of the arrow must be the shorter one or the smaller one. So 200 to 184, the only distance is 64, 16, 184 to 169, 15, 169 to 161, 8, 161 to 153 is the only 25, and this way. So it will reach to 25. Now there is no further request in this direction, so it will go to only two requests are remaining, 232 and 533. So of course it has to go to 232, and then only one request is 533. So this is the total. This one, this one, this one, this one, this all these distances you have to add it, and total comes out to be total seek length is nothing but 683, and average seek length is 683 divided by 8. The average is 85.37. But in case of previous one, the average is more than 100 or 150. Average seek length in case of FCFS algorithm, right? So that's why this SSTF always give you the optimum seek length here. So we are focusing on the seek length. So minimum distance should be traveled by that particular disk arm. There should not be any much movement, because if what happens if there is a maximum movement of the disk arm, so the disk arm is providing, or this arm is spending maximum time on just traveling instead of that executing. Getting my point or not? So what is happening? So if the length is much more, suppose instead of 185, suppose it is say for example 150. So 150 means it takes 150 minutes or 150 seconds or 150 milliseconds to reach to that particular destination, right? So traveling time is more as compared to the execution time. So ultimately your throughput of the system goes down. So that's why the algorithm must be such a way that it will give us the minimum. It will give us the minimum seek length, or the average seek length must be minimum or the optimum one, right? Now go to the next one, is nothing but the scan scheduling algorithm. In case of scan, you know that it will scan entire disk from starting from one end, reach to the another end, and again start from the opposite end, reach to the first the start destination, right? So start at 200 and always move toward the higher numbers. Always move toward the higher numbers. So remember in the scan, and hence whatever may be the algorithm after this scan, scan loop. So always the head move toward the higher order, higher numbers as compared to the current head. So it will move toward the 184, then it will move toward the 169, then it will move to 161, then 153, 128, then 25, and then it will move to 0. Then it will move to 0. So these are the distances traveled. These are the distances traveled by that particular head. Now when it, so this one extra bit is added here, means it will reach, because 0 is not included in the list, it is not included in the request, but 0 we have to consider, because from 25 it has to go to the it has to go to 0. Then 0 it has to again start to 232. Then it will go to 533, and then it will go to 639. So this is the another number, that is 639. So these are the two additional requests. These are the two additional requests added here in case of scan algorithm, because the head reaches to the extreme ends, or the start as well as the end point. So 839 divided by not 8, but here there are total 10 requests. So this is nothing but the total 83.9 will be the average sick leave, 83.9, because this one and this one is added here. 0 and 639, these two requests are being added here. That's why we have to divide it by 10. So this one. So this is the thing in case of scan algorithm. So see here, so it will reach to the 0, and finally it will reach to the 639. So in graph it is not visible, but it is reached to the 639 location. This is the location. You can say that this is nothing but your 639. Getting this point? Okay. Average sick length is equal to 83.90 because it is we have to divide it by 10. We have to divide it by 10, right? So just see it, the execution. Okay, the next algorithm is C-scan scheduling. So in case of C-scan, you know that it is similar to the scan algorithm, but only the thing is that it will not move toward the 0 or 639. It will reach to only up to the, in case of C-scan, it is a circular scan. It is similar to scan, but what happened while traversing in the reverse direction, it will not going to serve any request. While traversing in the reverse path, then it will reach to the start location and then start traversing again. And while traversing in the right direction, then and then only it will service the request. So see here. So in this case, always the head start moving toward the higher number. So from 200 to 232, then from 232 to 533, then 533 to it has to reach to 639 here. So see in this algorithm, particularly for C-scan algorithm, the head must start moving toward the higher number as compared to your current head location, but which is not true in case of your scan algorithm or previous algorithm. This is applicable only for the C-scan scheduling algorithm, right? So current head location has 200, so it will start moving in this particular direction. But in case of scan algorithm, it will not going to start in the higher order, right? So for the particular C-scan algorithm, this thing is true, right? So from 200, it will move to 232, then to 532, and from 532, it is the last request. It is the last request in this direction, but still, it will go to the 639, which is the end location, which is nothing but the last point on that particular disk. It will reach to 639. Now, as soon as it reaches to 639, it will reverse its direction. It will reverse its direction and reaches to the start of the disk. That is nothing but 0, right? But while moving from 639 to 0, it will not going to serve any of the requests. It will not going to serve any of the requests. Then it will start from 0 again and then start moving in the right hand side direction. And whatever may be the request coming in the path, it will be service, that is 25, 128, 153, 169, 184, and 184 is the last, because 200 is the already service. So total sequence is nothing but your 1262 divided by, again we have to divide it by 10, because there are two numbers are there, 639 and 0, right? So see here, right? So from 200, it will move to 232, always move in the higher order, higher request side. And from 232 move to 532. So 533 is the last request in this particular right direction, but still, as it is a circular scan, it will reach to the 639, which is the last location. And as soon as it reaches to the end of the disk arc reverse its direction and come to the start of the disk. That is nothing but the 0 location. But while coming in this direction, it will not going to serve any of the requests. So this path, you will see that this is the empty path. No request is being served while traverse in the reverse direction. Important point in case of your C-scan. So this is the difference between the scan and the C-scan algorithm. Just remember this point. Now, when it reaches to the 0, then it will start moving in this direction, and while moving in the right hand direction, whatever may be the request, that is nothing but the 25, 128, then 153, 161, 169, 184, all the requests are being serviced while moving in the right direction, right? So just see it once again. So average seek length is equal to 1262 divided by 10. So that is nothing but 126.20 average seek length or average seek time. Right. The next algorithm is your loop scheduling. So the difference similar to scan algorithm, but scan is not practically possible because scan algorithm the head reaches to the extreme ends, both ends, but it is not practically possible. So what is happening here? In case of loop algorithm, we have to go to the last request on both the direction or on either side. Means do not go beyond the last request, right? So here to go to the final request only. So again consider the starting position 200. So start moving in the higher order. Start moving in the higher request. So that is nothing but 184. Then 169. So it will move to 169. Then it will move to 161, 153, 120, 128, and from 128 it will go to 25, and 232 and 533. So how it will work? So see here. So 200, so start moving in this direction, 184, then 169, then 161, loop algorithm, then 153, 128, and it will move to 25, but it will not reach to the 0. It will not go to 0 because 25 is the last request in this particular direction. So immediately from 25, it will reverse the direction and start moving in this particular direction or start scanning in this particular direction because it is a loop algorithm. And while scanning, while moving in this direction, it will serve the request 232 and 533, but it will not reach to 639. It will not reach to 639. So this is the case. Look, average seek length is equal to 708 divided by 8 because there are only 8 requests. 1, 2, 3, 4, 5, 6, 7, and 8. 8 requests are there. So that's why we are dividing it by 8 only. Right. Then the next algorithm is nothing but your sorry. So this is all about the example. Now here is another example is given here for the study. A disk drive has, so the second example or the third example, disk drive has 640, again 640 cylinders numbered from. So this is the typing. Sorry, 640. So this number must be 200 cylinders because you have the cylinders number from 0 to 199. That's why 640 is the by mistake is typed here. So consider it as a 200 cylinders. So number from 0 to 199. The current head position is 53, and the head requests are 98, 1, 2, 3, 4, 5, 6, 7, and 8. Again, there are 8 requests. How many requests are there? 8 requests. And algorithms we have to study or we have to solve for the example FIFO, SSPF, scan, C-scan, and loop algorithm. Okay, so only see here the logic and everything is same here. Only numbers are different. So in previous example, 0 to 639 is was the number, but in this case 0 to 100, 199 is the number, and the requests are different. In the previous example, the requests are different. Here request is the difference. Sorry, here is the difference in the request. Right. So see, first one is
Hello, 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 hello. One up. Hello, sir. Sir.
सर आज ही नहीं तुम सर सर
हाँ, बोल ना, बोल ना, बोल ना, बोल ना, नाही आवाज. हॅलो ना.
अरे मला माहिती आपल्याला दोघांनाच होत बाकीच्या कोण होत?
काय माहिती यार, काय काय नाही, कोणी काय बोलणार नाही. हो ना, बोललो सरांना बोललो.
हॅलो सर हॅलो हॅलो
Hello? Hello? Is it okay now? Hello?
Yes sir, yes sir.
Audio is clear? Okay. So, we are discussing this scan scheduling algorithm. So, in case of scan scheduling algorithm, the current head location is 53. So, from 53 current head location, the disk arm try to move toward the 0, because 0 is the end. So, always remember, in case of scan algorithm, the disk arm try to move towards that particular end which is nearer to that current location. So 53 is the location. So out of, so in compare between 200 and 0 or 1990, which is the nearer. So 0 is nearer. So arm try to move towards the 0, or arm will move towards the 0. And while moving towards the 0, these are the requests. That is 50. That is the 3740. The requests are service, and then it will move to 0. Then it will move towards the 0. And from 0, as soon as it reaches to the end of that particular disk, or end means it is the starting point, then it will reverse its direction, then it will move towards the reverse direction, and whatever may be the request come across that particular path, 65, 67, 98, 122, 124, 183, and 199, that will be service. And this is the last 199. So these are the two requests are being added, 0 and 199. So see here, total seek length is 252 divided by total requests are now, instead of 8, we have mentioned here 10, because total requests are now becoming 10 here. The average seek length is 25. Average seek length is 75. So this distance, 14 to 0 and 0 to 15. So this distance is added extra here. This much distance is added extra, and from 183 to 199, this much distance is also added extra here, right? So because this is the scan logic, this is the logic of the scan algorithm. But and this is removed in case of your which algorithm? In case of your look algorithm. So in case of look algorithm, so it will not move towards the 0, or it will not move toward the 199. Whatever be the request which is the last in that particular direction, immediately from the last request on that direction, the head changes its direction, right? Next one is nothing but the C scan or the circular scan scheduling. So circular scan scheduling means the same as that of your scan algorithm, but only the thing is that it will reverse the direction. But while moving across the reverse direction, it will not going to service any request. So from 53, it will move to 65. And in case of C scan algorithm, one important point we have to remember that always it will move always toward the higher number, or it will always move current location. The higher number is 65. It will move to 65, and it will not move to 14 here. See this point. So in case of circular scan, always remember that it will move always toward the greater number as compared to the current head position. 67, then 98, 122, 124, 183, and 199 is the this is the one can say end of the disk. So at the end of the disk, it will immediately reverse the direction. But while reversing the direction, whatever the request came across, it will not going to serve. This is the empty path, or this is nothing but the empty channel here. And then from 0, it will start moving in this direction. And the requests are 14 and 37. They are coming across this particular path, and that will be service. So total seek length is nothing but your 382. Average seek length is 382 divided by 10 is equal to 38.20, right? The next algorithm is nothing but your loop scheduling. Scan is not practically possible. It is similar to scan algorithm, but head does not reach towards the end. Already we have seen this. So meaning is that, see here from figure, so similar to scan, it will move to 53 to 65, 67, 98, 122, and in this loop algorithm also, in case of loop scheduling algorithm also, the disk are move toward the higher number, means 53 to 65 to 67 to 98, means in the higher order number it will always move and try to reach toward the 183. But in case of scan algorithm, the head starts its movement in the direction 14 and then 37. 37 here first is the 37 and then comes out to 14 and then it reaches to 0. This is in case of your scan, but in case of loop algorithm, it will reach toward, it will start from the higher numbers which are higher to the current head position, and then reaches to 183, and it will not move toward the 199 here. And as soon as it reaches to 183, which is the last request on that particular direction, means on the right hand side direction, immediately reverse the head and move toward the last request on this particular opposite direction. It will not move towards the 0. It will not move towards the 0. It will move up to 14 only. So this is the difference. This is the difference in case of your scan and look algorithm. So from 14, it will again reverse the direction in this direction, and only one request is coming across the path, that is nothing but 37. The total seek length is 322, and average seek length or the average seek time is nothing but 322 divided by 8, that is nothing but your 40.25. Okay, so that's all about the examples. So we have seen the three different examples on this algorithm, that is FCFS, SSTF, scan, C-scan, look, and C-look algorithm. So these are the references you can refer. Better way, you have to go for the Galvin, the best book for the operating system, and NPTEL video lecture link, as well as you can NPTEL the best resources, best video you can find on this particular website. All are the IIT video lectures are there, and web resources are also available. Okay, so let us stop here for the today's lecture. So whatever may be the remaining part, that will be continue in the next lecture, right?